right, today we're jumping into a topic that's at the very core of every single project you can imagine, from launching a rocket to, well, planning a party. We're talking about managing uncertainty. So let's get into it and see how the pros handle all the things that could go wrong or right. I know. That sounds like the beginning of a weird joke, right? One involves astrophysics and budgets with lots of zeros. The other involves a good playlist and hoping your cousin doesn't show up. But they share one fundamental, absolutely unavoidable thing. Yep, uncertainty. Will a critical rocket component pass its stress test? Will it rain on the day of your outdoor party? Both of these things are just swimming in what-ifs, and the whole game of project risk management is about mastering those what-ifs. Okay, so before we can even start to manage risk, we've got to make sure we're all speaking the same language. Let's nail down some key terms, because when you're managing projects, words have very, very specific meanings. So here it is, the official definition. But hang on, did you catch that? The most important part here is positive or negative. We almost always think of risk as a bad thing, a threat, but it can also be an opportunity. An unexpected breakthrough that lets you finish ahead of schedule. So you can pretty much sort all risks into two big buckets. The stuff you can kind of see coming, and the stuff that comes completely out of left field. For the known risks, like a supplier who's always late, you set aside a specific safety net. That's your contingency reserve. But for those truly bizarre, unpredictable, unknown risks, the stuff you literally can't imagine, you need a general uh-oh fund. That's your management reserve. Here's a great way to think about this one. Inherent risk is just the basic fact that if you go outside on a sunny day, you might get a sunburn. It's the risk that just exists. Residual risk, that's the small chance you still get a little burned even after you put on sunscreen. You've taken precautions, but you can't get the risk to zero. That little bit that's left over is your residual risk. Okay, so now we've got the vocabulary down. What's the actual game plan? Well, it turns out it doesn't matter if you're building software or building a skyscraper. The process for wrangling risk follows a clear, structured playbook. And here it is, the 7 steps. It all starts with planning how you're even going to think about risk. Then you hunt them down, you analyze them, you figure out what to do, you actually do it, and then you keep watching. It's a full cycle. And what's really cool is how this same exact playbook can be used in 2 totally different ways. And this, for me, is where it gets really fascinating. Everyone uses that 7-step playbook we just saw, but how they use it? Well, that's where you see a huge split between 2 mindsets, the super structured traditional approach and the super flexible agile approach. This analogy just nails it. The traditional method is all about predicting the future. It's like planning that road trip with a paper map, marking every single turn and hotel before you even get in the car. The agile method, on the other hand, is all about adapting. It's like using a live GPS. You know your destination, but you're constantly reacting to traffic jams and finding new routes on the fly. One isn't better than the other. They're for different kinds of trips. So how does this actually look day to day? Well, in a traditional project, the project manager is in charge, creating a big formal risk document called Risk Register. In an agile project, risk isn't some separate thing. It's just another task in the backlog that the entire team talks about. In traditional, you track risk in a spreadsheet. In agile, you track it on a big visible board that everyone sees every single day. Okay, that's enough theory. Let's get our hands dirty. We're going to look at some of the actual tools project managers use to fight risk, starting with some good old-fashioned detective work, and then moving into some cold, hard calculations. First up is a tool that's all about putting on your detective hat. It's called root cause analysis. And one of the simplest ways to do it is with a technique called the 5 whys. The idea is you don't just fix the surface problem. You keep asking why until you find what's really broken underneath. So let's run through a quick example. Your project is late. That's the symptom. You ask the first most obvious question, why? Well, because the developers missed their deadlines. Okay, fair enough. But a good detective never stops there. So we ask again, okay, why did they miss their deadlines? Turns out they were just getting slammed with constant bug fixes and having to rewrite code over and over. We're getting warmer, but that's still not the real problem. So why were there so many revisions? And aha! It's because the project requirements, the actual instructions for what to build, were vague and they kept changing. Now we're getting somewhere. See how we're peeling back the layers of the onion?
So why were the requirements so messy? Well, it turns out the key decision makers were all telling the development team different things. We've just gone from what looked like a technical problem to what is clearly a communication problem.
And finally, our fifth why. Why were they getting conflicting info? Because there was no system in place, no formal process to get everyone in a room and agree on the plan. And that is the root cause. It wasn't bad developers, it was a broken process from the very beginning. Okay, so that was a qualitative tool. It's all about understanding the story behind a risk. But what about when you need to make a decision based on numbers? How do you choose the best financial path when you just don't know what the future holds? Well, you let data guide you. So check this out. Imagine a company needs to upgrade its servers. They've got two choices. They can build a whole new system. It costs a ton, but the potential reward is huge. Or they could just upgrade their current system. Cheaper, but with a smaller payoff. The big unknown is whether customer demand will be strong or weak. How on earth do you choose? You calculate something called the expected monetary value, or EMV. It's basically a weighted average that factors in the probabilities. For that big, expensive build new option, when you crunch the numbers, the 60% chance of a big payoff and the 40% chance of a smaller one, the total expected value comes out to $3.6 million. Now let's do the same exact math for the cheaper upgrade option. You run the numbers and look at that. The weighted average comes out to $4.6 million. This is so cool. Even though building new had that massive potential jackpot, the math shows that upgrading is actually the smarter, more valuable bet when you account for the risk. The data gives you the answer. But wait, there's one final crucial piece of the puzzle. You can have all the tools and all the data in the world, but every decision still gets filtered through a very powerful lens: human psychology. How you or your company feels about risk changes everything. Most of us fall into one of three camps. Risk-averse people will always choose the safest path. Risk-neutral people are the ones who just follow the math. They'd pick the option with the highest EMV. And then you've got the risk-seeking folks who are willing to take a big gamble for a huge reward. So back in our example, the risk-neutral person picks the $4.6 million option. But a risk-seeking CEO, they might still go for building new, chasing that $20 million prize, even if the math says it's less likely to pay off. So ultimately, managing risk comes down to choosing your philosophy. There's no single right answer for every situation. Which brings us to the final question I want to leave you with. For your next big challenge, are you going to be the planner with the detailed paper map? Or are you going to be the adapter with the live GPS, ready to react to whatever the road throws at you? Your answer will define your journey.